Hi guys, now we're on lesson 3-4. It's solving multi-step inequalities, and you're going to see it's a lot like when we were solving the multi-step equations. Okay, so problem 1, we're starting off with just two-step inequality. So it says, what are the solutions of, and problem 1 is 9 plus 4t is greater than 21. So we want to solve this for t. So by now we should be pretty good at solving these two-step equations. You can still do the box it in the Bridget thing if you want for inequalities. That's fine. It's the same thing. So first thing we want to do is subtract 9 from both sides. So we have 4t, and then you just drop down the greater than symbol. And 21 minus 9 is 12. And then we're going to divide both sides by 4, and we're going to have t is greater than 3. And that would be your inequality. So all the numbers that are greater than 3 would be a solution to that inequality. Okay, and number 2 is negative 6a minus 7 is less than or equal to 17. So if a is the variable we're solving for, we want to box that, save that for the end. So we're going to add 7 to both sides. So we have negative 6a is less than or equal to 24. Okay, and now to solve for a, we need to divide both sides by negative 6. And remember, when you divide by a negative, you have to switch the inequality. So I always switch it right away so I don't forget. Negative 6 divided by negative 6 cancels out. So we have a is greater than or equal to negative 4. So now all of the numbers that are greater than or equal to negative 4 would be a solution to that equation. So that's how you solve two-step inequalities. Now problem 2 is a word problem. So if you have your book, it's page 187. It says, in a community garden, you want to fence in a vegetable garden that is adjacent to your friend's garden. Adjacent just means like right beside each other. Like my classroom is adjacent to I think it's the boys' bathroom, like they're right beside each other. Okay, you have at most 42 feet of fence. So what are the possible lengths for your garden? Okay, so if you're going to fence in something, you have to at least use this equation. Perimeter equals 2 times the length plus 2 times the width. Now, it's not actually going to be an equation, but that's the formula that you're going to use. So, just going by what the book said, it has let L equal the length of the garden. So, we have this garden here, and here's your friend's garden. And you want to put, oh, sorry, this part over here, I don't know, this is just vegetable or something. This part in the middle, this is your friend's. Okay, and you want to make your new garden, the book kind of shows you something like this, here's your possible fence. But it also tells you that this length right here, I mean, this is important. If you didn't have your book, you wouldn't be able to see this. This length right here is 12 feet. So that means that this length over here is also going to have to be 12 feet if you're going to fence in a rectangle. Okay, so pretty much how big do we make these side pieces if we have at most 42 feet of fence? Okay, so we want to go with the perimeter equation, but we want to make it an inequality because, so let's see, we have 2L plus 2W. Now, this is the perimeter. This 2L plus 2W represents the perimeter. We want to make sure that that is less than or equal to 42 because that's how much fence we have. Okay, so if this is the length right here, if this is what you're trying to figure out, you still have 2L. Now, for the W, you know that value. You know the W is 12. Okay, so we're going to put a 12 in there, and it still has to be less than or equal to 42. So if we solve this for L, so let's see, we have 2L plus 2 times 12 is 24 less than or equal to 42. Subtract 24 from both sides. We have 2L is less than or equal to 18. Divide both sides by 2, and we have L is less than or equal to 9 feet. Okay, so anything that's less than 9 feet, you would have enough fence for. So if you want to use all 42 foot of your fence, you need to make your length going this way 9 feet. If you want to have a couple extra feet, anything less than 9 feet would work. So we're going to do a lot more word problems. We're going to do a whole page of word problems. Okay, so we'll practice that more later. Okay, problem 3 is distributive property, and I apologize, when I did this in the PowerPoint, it got like really messed up, so I crossed some things out and I rewrote them. But problem number 1 is 3, and then in parentheses, t minus 1, minus 4t is greater than or equal to negative 5. Okay, and this is something I told the pre-algebra kids when we did this. It might help. I made them repeat after me. I will only distribute what is touching the parentheses. So maybe that'll help you, because this same stuff, maybe if we had trouble with it in chapter 2, we get to practice it again now, so it's good. So distribute, and we have 3t minus 3. Then we still have minus 4t is greater than or equal to minus 5. Now the 3t and the minus 4t, we can combine those, and that's going to be minus 1t minus 3 is greater than or equal to negative 5. Then to solve for t, we need to add 3 to both sides. So we have minus 1t is greater than or equal to negative 2, and then divide both sides by negative 1. And when you divide by negative 1, you have to flip the inequality sign. So we have t is less than or equal to just 2. Okay, and looking at the book now, I still copied it down wrong. It was supposed to be t plus 1, but don't worry about it. We did t minus 1. We got an answer, so we're good. Okay, and problem number 2 is 15 less than or equal to 5 minus 2, and then parentheses 4m plus 7. So if you go with what I told you before, you're only going to distribute what is touching the parentheses. So we still have 15. We still have less than. We still have 5. Now, the negative 2 is what's touching the parentheses, so that's what gets distributed. So we have negative 2 times 4m. That's going to be negative 8m. And then we have negative 2 times a positive 7, which is going to be negative 14. Okay, this time we have numbers that are like terms. So 5 minus 14, we need to combine them. So we have 15 is less than or equal to 5 minus 14 is negative 9. So I'm going to write minus 8m minus 9. Then to solve for m, we need to add 9 to both sides. So we get 24 is less than or equal to negative 8m. And we divide both sides by a negative. We have to flip the sign around. So I'm going to, instead of it being less than, it needs to be greater than. We have m on this side, and we have negative 3 on this side. So you can leave it like that, but I always like to flip them around. I like to make it m is less than or equal to negative 3. Okay, so that's solving inequalities, using the distributive property. Okay, now we have variables on both sides, just like with equations. So the first one is 6n minus 1 is greater than 3n plus 8. Now, remember, when we had variables on both sides, the goal is to get the variables on the same side and then the numbers on the other. So I'm going to subtract 3n from both sides to cancel out the 3n's over there. So 6n minus 3n is 3n. I still have minus 1 is greater than 8. And now we just have a two-step equation. So add 1 to both sides. We have 3n is greater than 9. Divide by 3, and we have n is greater than 3. Okay, and problem number 2 is 3b plus 12 is greater than 27 minus 2b. Now I have b's over here, and I have b's over here. The easiest thing to do would be to add 2b to both sides, because a minus 2b plus a 2b would cancel out. So 3b plus 2b is 5b plus 12 is greater than 27. So now a two-step inequality, subtract 12 from both sides. I have 5b is greater than 15. Divide both sides by 5, and I have b is greater than 5. Okay, so there's solving inequalities when you have variables on both sides. Okay, and problem 5 is inequalities with special solutions. So remember before when we had all solution or no solution? That's going to be the same thing that we have here. Okay, so number 1 is 10 minus 8a is greater than or equal to 2, and then in parentheses, 5 minus 4a. So we have parentheses, which means we need to distribute. You're only going to distribute the number touching the parentheses. So the left side is still going to be 10 minus 8a. And then the right side is going to be 2 times 5 is 10. 2 times negative 4 is going to be minus 8a. Now if you look at what we have 10 minus 8a is greater than or equal to 10 minus 8a. If you wanted to, you could get the variables on the same side. You could add 8a to both sides, but you're still going to get the exact same thing. 10 is greater than or equal to 10. Okay, so in this case, since 10 is always greater than or equal to 10, is always true, so the solutions would just be all real numbers. Any number that you plug into here is going to make this equation true. Okay, now you have to be really careful, because if this would have just been 10 is greater than 10, that's false. So then that's going to be no solution, but that would be a different example. Okay, so if it's 10 is greater than or equal to, because it could be equal to, that's all real numbers. Okay, number 2 is 6m minus 5 is greater than 7m plus 7 minus m. So instead of having distributive property on this one, we have combining like terms. Oh yeah, and this is going to be the one I was talking about. So on the right side, 7m minus m would be 6m plus 7. And then on the left side, we still have 6m minus 5. Now if I get variables on the same side, subtract 6m from both sides, and the m's cancel out. So I get negative 5 is greater than 7. Now, that's not a true statement. So this is a case where it's no solution. Now, I don't want you to think just because you got different numbers, it's no solution. If by some chance we would have gotten 8 is greater than 7, that's always true. So in that case, it would have been all real numbers. Okay, so it wasn't no solution because we got two different numbers. It was no solution because we got a statement that was false. Negative 5 is not greater than 7. That's what made it no solution. Okay? Okay, and then 2 more. So number 3 is 9 plus 5n is less than or equal to 5n minus 1. So we have variables on both sides. We need to get the variables on the same side, so subtract 5n from both sides, and the n's cancel out. And this time we have 9 is less than or equal to negative 1. Now, is that true? Because 9 is greater than negative 1, that's false, which means this has no solution. There are no numbers that you can plug into that inequality that's going to make that inequality a true statement. Okay, and last one, number 4, we have 8 plus 6x is greater than or equal to 7x plus 2 minus x. So over here, we have to combine like terms on the right side. So we still have 8 plus 6x greater than or equal to. Now 7x minus 1x is going to be 6x, and we still have plus 2. Get variables on the same side, so we need to subtract 6x from both sides. The x's cancel out, and we have 8 is greater than or equal to 2. Now that's a true statement, so no matter what number you plug in is going to make this inequality true. So the answer to this one is all real numbers. Okay, and that's it for lesson 3-4.